Hey everybody. So this is going to be a quick video showing you how to do a simple linear regression. Now I've already aggregated the values of my scales. I've created a total scale, an average scale for NLE. And the reason I created a total scale here is because of the way the questions are asked. So on this scale, which is, it's labeled NLE because it stands for negative life events. um, Basically you're asked for a series of items, whether you have experienced this thing or not. One was given a value of yes, two was given a value. Yes was given a value of 1, no was given a value of 2. So I recoded it such that no equals 0 and added them up. So now as numbers grow higher on NLE tote, you've experienced more negative life events. OSSS is a scale of social support. And so after reverse coding and aggregating, higher numbers on that scale mean that you experience more social support from your family, friends, etc. And then BDI, that is your it's a depression inventory. So this is going to be a measure of your depressive severity. So we're going to run a simple linear regression. We're going to see what the relationship between negative life events total is, and depression, and social support and depression are. So we're going to do those. We're going to do those two simple linear regressions. And to do those, we're going to come to, and again, just really quickly, before you can run this, you've got to do all your aggregating. You've got to get all your scales into single. You got to get all your sum scores or average scores from your scales. You can't walk into this not without having checked the reliability and aggregating your scales. Okay, so first we're going to run a regression to see if negative life events predicts depression, and what we might expect is that as depression increases, as negative life events increase, so would depression. Now, mind you, we only have like 35 participants, so we have basically no power to speak of. All right, and this is so don't, and you shouldn't take any of these results as indicative of anything about the actual relationship between negative life events and depression. This is literally just a tutorial video. Okay. All right. So we're going to run the simple linear regression. We're going to click Analyze, Regression, and we're going to come over and we're going to go to Linear. I'm going to click that. Now I've already populated some of these, so I'm just going to click Reset real quick. So because our outcome variable, what we're wanting to predict, depression, is depression, then we're going to put that up here in the dependent folder or box, even though it's not truly a dependent variable because we haven't manipulated anything. But it's what we're trying to predict, so it's our outcome variable. So we put that up there in the dependence box. Now again, we're going to try and look at its relationship with negative life events. So we're going to try and predict depression from negative life events. Okay. So I've got those two variables in there. I'm going to click OK, and here's our output. So if we go through this, all right, this is the first one that we might look at. This tells us basically what percentage, or not what percentage, what amount of variance in the outcome variable, depression, is accounted for by variance in our predictor, so negative life events. And we want to get a proportion, which is more easily understood. We look at the R square, all right, and that's 0.048. This is the proportion of variance in our outcome variable, depression, explained by variance in our predictor, negative life events. So about 4.8% of the variance is explained. We come down here to our coefficients table. The ANOVA table tells us whether or not that's a significant proportion. It's not. All right. The coefficients table tells us specifically if we were to create a line predicting depression from negative life events, how much would that line become positive? So if it's flat, right, that means there's no relationship. This beta right here tells us how much that line grows if there's a positive relationship, or drops if there's a negative relationship, and whether or not that difference from flat is significant. All right, and the difference isn't significant. All right, but it is going in a positive direction. So if we look at the standardized beta, we can interpret the standardized beta largely like we do a correlation. So, you know, up to, if it's a positive number, then there's a positive relationship. And although there's nothing mathematically preventing it from exceeding 1 or going below -1, usually it's between -1 and 1. And so you can largely interpret the standardized beta the same way you would interpret a correlation. So you can see there's a weak positive relationship. So in general, as people experience more negative life events, because that's our predictor, they're experiencing greater depression, which is what we'd expect. But again, we only have 34 participants, so again, we have no power to speak of, and again, this is just for demonstration. This tells us nothing actually about that relationship. Now, so we've run our regression looking at depression being predicted by negative life events. What about the relationship between depression and social support? So we're going to check that out by going to Analyze, Regression, Linear. We're going to swap out negative life events for social support. I'm going to pop that over there. And we're just going to run it. Here is our new output. So again, all right, in the model summary, we can see by looking at the R-square, we can see the proportion of variance in depression accounted for by our predictor, social support. So about 11% of the variance and I'm doing that by moving that decimal over twice. All right, so about 11.1% of the variance in depression is being accounted for by the variance in social support. And that's I'm going to call that significant, all right, at the 0.05 level. All right, if we round that, it would be 0.05. Now, if we come down here to the coefficients table, we can see how much that line departs from being flat. Well, if we look at the standardized beta, all right, we've got -0.333. All right, that tells us that that line is negative. So that means as social support grows, depression drops. All right, and it does so significantly. All right, the relationship isn't necessarily strong. It isn't the strongest. It's about a little stronger than a weak relationship, but it's the way we would expect it to. You know, as you have more social support, you have less depression. Now, again, I've said it twice now. I'll say it again. This tells us nothing about the actual relationship between social support and depression, because this is just for demonstration's sake. And we only got 34 people. All right, but that's what you would look at, and that's how you would interpret a simple linear regression. Now, if I were reporting these regressions, then I would report the R-squared by writing capital R squared equals that, 0.111. All right. If I wanted to explain the effect of social support on, or not the effect, but the relationship between social support and depression, I would write the Latin letter B equals this, all right, comma, lowercase italicized b equals that, that's your standardized B, comma, italicized SE, standing for standard error, equals that, comma, T, and my degrees of freedom are right here, all right, 34, equals 2.029, comma, P equals 0.051. So seeing that written out, give me a second, I apologize. It would be please bear with me, I apologize. There you go. So you've got your standardized beta with the number. All right, so I'm gonna unshare right quick. So here's the number, right? So you got your standardized beta with your number, with the standardized beta, your unstandardized beta with its number, your standard error, your t-value with your degrees of freedom, which you get from the ANOVA table, the t-value. Now I'm taking off the negative because the negative is largely irrelevant. All that tells you is distance from zero. That's all this t is testing, is distance from zero. So if this is negative, this is going to be negative. If this is positive, this is going to be positive. All right, so all this t, the important piece of information from the t really is deviation. Is it a significant deviation from zero? And in this case, that looks like an S, but that's a 0.051. It is. All right, so these are the statistics that you would run with this, or that you would report with a simple linear regression. And that, my friends, is that. All right, guys, as always, if you have any questions, let me know. If not, take it easy.